So here's another good problem on related rates. We see these kind of problems pretty much every year. So, and we actually have done it, but I just want to cover it one more time, just talk about it quickly. Here's the person, here's the, in red, it looks horrible, but the spotlight, and the person is walking away from this spotlight towards this wall, and the rate is given 2.5 feet per second. Here's my little person, 6 feet tall. The shadow is gonna be on in this case when you're walking towards the wall and spotlight is behind you, so the shadow is right on the wall. It's not given. This is the only information we have. So this rate, the whole distance, by the way, from the base of the building to the spotlight is 20 feet. That's it. So these kind of problems, they all have the same type of procedure. You use the same type of techniques. So you use similar triangles, obviously. What else can you do? It's not a ladder problem. So you have to consider these two triangles, one right here, the small one, and the other one is the bigger one, right? In order to make a proportion, you want to make sure you have enough information, including the variables. So let's say distance from here from the person to the spotlight, we don't know what it is. It's part of your small triangle. You're going to label it X. Let me use the red color. So it's X. Now the person's height is 6. So you have two parts of your small triangle. Now let's see what we have in terms of corresponding sides. So look at the big triangle now. This is your X, small triangle. Now corresponding would be this whole length, and that's 20, that's given, good. We need one more parameter. So we have the person's height at 6, so corresponding side is right here, and it's not given, so you have to label it. So let's use Y, and that's about it. Oh, by the way, they want you to find, I didn't even tell you what you need to find, so this is all given. They want you to find dy dt. So the shadow is on the wall, and they want to know the rate. Oh, it's getting smaller and smaller, so they want you to find the rate. Okay, so you need to make a proportion here. So we're going to use these two small triangles. We're going to start with, it doesn't really matter. For some reason I always start with large triangle. So a y over what corresponds to y, 6, equals, back to large triangle, 20 over what corresponds to 20, x, and that's it. Now we want to find dy dt, so that's why from this proportion you want to solve y, because you're looking for dy dt. If you had to solve for dx dt, then you would solve this proportion for x first, because I'm going to differentiate. So this is how I'm going to get dy dt. Let's see, y equals 6 cross multiply. 6 times 20 is 120 over x. Got it? Now we're going to find dy dt equals, I'm going to rewrite it. I hate the quotient rule, so I'm going to do 120 x to the power of -1 prime. So that will be negative 120. Derivative of x to the -1 is -1 over x squared. And times, because x is changing, the person is moving, so this distance is changing at a certain rate, dx dt, which is given, by the way, right here, see, 2.5 feet per second. Now one more piece of information I did not give you, but it is given. It says you need to find the rate of the shadow when a person, at a certain moment, when a person is 12 feet away from the wall. So that's given too. So let's see. So it's going to be negative 120 over 12 squared, right? Okay, sorry, I had to pause. My dog did something terrible. I apologize. Got distracted. So negative 120 over x is 12, that's given, squared, times. The x dt is also given, it's 2.5. And if you do the math, you will get your answer, and it has to be obviously in feet per second. I hope it's okay that I didn't solve it completely, so I'm sorry. Hopefully it makes sense. Let me know if you didn't understand.